お時間となりましたので、次のセッション、
Well, it's time to
ソー
start
シ
the
ャルグ
next
ッドのため
session,
のデータサイエンスと AI、
which is Data
交
Science
通
and
と
AI for
モビ
Social
リテ
Good,
ィ、
a
アプリケーションに
collaboration on
関する
transport and
日英コラボ
mobility
レーションを
application.
開始いたします。進行は英国大使館国際通商部より大英投資首席担当官永瀬修子
And
様が務め
from
ます。
the UK
それで
embassy
は
in
永瀬
Tokyo,
様、
we
よろし
have
くお願いいたします。
Nagase-san from International
それ
Commerce
では始めさ
Department
せ
who
ていただ
serves
き
as
ま
an
す。
MC
皆
here
様本
today.
日はご視聴くださいまし
Nagase-san,
てあり
please.
がとうございます。私ただ
My
いま
name
ご
is
紹介をい
Nagase.
ただ
Thank
き
you
まし
very
た
much
駐
for
日
kind
英国大使館国際
introduction.
通商部の永瀬と
I'm
申しま
from
す。どうぞよろしくお願
International
いいた
Commerce
します。
Department of UK
英
Embassy
国
in
大使
Tokyo.
館では先週
Very
よ
good
り
to
フュー
meet
チャーオブ
you.
モビリティグ
From
レート
last
シー
week,
ズンと
the
題す
British
るキャンペーンを
Embassy
立ち上げまして
launched a
モビリ
campaign
ティ
called the
分野
Future
で
of
の英
Mobility
国の
Great
競争力
Season.
を皆様に知っ
And
ていただけま
in
すよう
order
これから
to,
数ヶ月をかけてキャンペーンを展開してまいります。
let you know of
本
the
日のセッション
UK
はそのキャン
competitiveness
ペー
in
ンの第
mobility
一弾
area
と
for
し
the
ま
next
して
several months.
英
We
国のア
are
ラン・チュー
going
リング
to
研究
run
所
multiple
並び
different
にトヨタモビ
promotions.
リ
And
ティ
today's
出演
session
取
is
締
a
スピー
part
カー
of
お
the
二人をお
campaign.
招きして
And from
日英
UK,
2つ
we
の組織
have
による
the
共同研究
speaker
プロジェクトについ
from
てご紹介をいた
Alan
だきます。
Turing Research
お二人のプ
Institute,
レゼン終了
as
後
well
に
as
Q&A
we
のお
have
時間を
another
設けており
speaker
ますの
from
で
Toyota Mobility
YouTube のコメン
Foundation.
トファンクションを
And
ご使
we
用
are
の上
going
どう
to
ぞ
have
スピ
them
ーカーのお二人へ
introduce
の
the
ご質
joint
問を適
research
切な
projects
参
that are
加いただけれ
ongoing,
ばと
as
思い
well
ま
as
す。
at the end of the presentation of these
それで
two
は早速
gentlemen,
ですが、スピ
we
ーカー
have
のお二
Q&A
人より簡
sessions.
単な自己
And
紹
so
介をお
if
願
you
いいた
can
しますで
actually
しょう
use
か。
the YouTube's
まず
comment,
はトヨタモビリ
function
ティ基金
to
グ
ask the
ローバ
question
ル
to
リ
the
サーチ
speaker.
イ
And
ノベー
first,
ション
I
シニ
would
アマ
like
ネー
to
ジャー
ask
ウィリア
Senior
ム・チャー
Manager
ニク
Global
博士か
Research
らお願いいた
Innovation
し
of
ま
Toyota
す。
Mobility Foundation, Senior Manager Dr. William Charnikov, please.
Yes, thank you. It is truly an honor to be able to participate here, and thank you for the kind introduction. My name is William Chernikoff, and I do have the privilege of leading the Toyota Mobility Foundation's Global Research and Innovation. And this program aims to develop the capacity, the knowledge, and the tools to enable our regional directors and our project managers to bring new and effective mobility solutions to our local partners on the ground to both solve the immediate mobility challenges that many people are facing, as well as really seek the capacity to solve the most pressing problems so that we have new solutions that we can bring forward tomorrow. And I'm excited to be able to share one of those highlights of those projects that's the result of our partnership and collaboration with the Turing Institute. So, thank you.
ウィリアムさんありがとうございました。
Mr. William,
それ
thank you
で
very
は
much.
続きましてアラン・チューリン
And
グ研
next,
究所
from the Alan Institute, Alan Turing Institute, Mr. Damon Wittig, please.
Hello, it's a great pleasure to be here. I first traveled to Tokyo 12 years ago and I'd have loved to be there again, but alas, I'm in Cambridge on a rainy English autumn morning. I'm a fellow at the Alan Turing Institute, and I'm also at Cambridge University where I lecture in data science and machine learning. The Turing Institute does have some permanent staff, but most of its fellows are, like me, university academics who spend some time each week on a Turing Institute project. The Turing Institute has several projects that fall under the heading of urban analytics, for example, work on digital twins, on mobility models and on air pollution. And I'm the lead on the project that we're doing with the Toyota Mobility Foundation. We've been working together on this for about 2 years now, and I'm very excited to be working on this. It's a culmination actually of a line of work that I began 8 years ago in a startup in Silicon Valley, but I just decided Silicon Valley didn't have the resources that we needed for something of this scale, and it's much better to be working with the Toyota Mobility Foundation and with the resources of the Alan Turing Institute.
Mr. Damon, thank you very much for your kind introduction, and then we will ask these two gentlemen to present, but before that, the Alan Turing Institute of the UK and also the Toyota Mobility Foundation, which was established by Toyota Motors Corporation. And you might think that the collaboration between these two organizations may be very interesting combination. And with regards to the direction of these two organizations, as well as the background of starting this joint research to be started, if the two speakers could introduce some of this background information first, with Mr. Damon, please.
Background about the Turing Institute and what it does and why it's working with Toyota Mobility Foundation. The Turing Institute calls itself the UK's National Institute for Data Science and Artificial Intelligence. It was set up in 2014 as a program by the government, and it was initiated by the government with 5 initial university partners. And it was really set up to be something which is somewhere in between what government does, what universities do, and reaching out to charities and to industry. It's not a research lab in its own right. It's really a meeting point where people can come together to work on projects that can use data science and machine learning for social good. And I think that's really why it was such a natural partnership to work with the Toyota Mobility Foundation. We're not working on a small, narrow project of, can we train an AI to do very well on some limited task? We're trying to work on problems which will have societal impact. This is something that the Turing Institute has had as part of its DNA from the beginning, and it's why it was so natural for us to partner with the Toyota Mobility Foundation.
Yes, thank you, Damon. I think you covered it very well in terms of the synergy between our two organizations, particularly the motivation to work for the social good. Just a little bit more background on the Toyota Mobility Foundation, and maybe this can be a lead-in to my presentation, but I do want to make clear that, as the Toyota Mobility Foundation, we are a separate entity from Toyota Motor Corporation. We operate under Japanese non-profit law. We have a global reach, but one of the big differences is our mission around benefiting society, and our approach to solving these problems is mode and technology agnostic. And this affords us the ability as well to work with many companies in many countries, and support local innovation and startups, and work with more strategic partners like the Alan Turing Institute on some of these broader cutting edge challenges, where the end objective is to deliver solutions, some of which, including what we will talk about, are open source and intended not to drive profit generation, but to benefit society. So with that, may I start our more formal presentation?
Yes, go ahead.
Okay, thank you. Yeah, so I already mentioned and gave a little bit of background on who the Toyota Mobility Foundation is. I'd like to now highlight what our mission is, and this is centered around the idea of to enable more people to go more places. And fundamental to enabling us to do this and bringing value to people in communities around the globe is our partnerships and our collaborations to bring the resources to bear, the different expertise and perspective that different organizations and companies have. Some of this is done at the local level. Solutions really need to support the culture and the community where we operate. And some of the problems that we are tackling, as the example that we'll share in a moment, require much more strategic partnerships, and that's why we've reached out to the Alan Turing Institute to tackle this very challenging problem around mobility system management. So how do we go about this work?
ではどのよ
There's
うにして
really
これを行うのか。
two ends of the spectrum
2
that we
つ
try to operate at.
我々がやろうと思っていることがございます。まず1つ目、
Looking at the individual level, what we call the personal
インディビ
mobility,
ジュアルレベル、つまり個人
improving
のモビ
the
リテ
access
ィ、
to mobility,
つまりモビ
the
リティへのアク
affordability,
セス
really focusing on and
や
ensuring
手頃
that
感
those who
な
are
ど、
typically underserved
通
or at
常
risk for
十分
any
にサービス
range
され
of
ていない
reasons
人、何か
are being able to
理由
get
があっ
access
て
to the mobility solutions so that they can fully participate in society, in the economy, and live a full life. On the other end is this idea of harmony and mobility. This is a broader view of the work we do about improving community access in these larger systems, whether it's local communities up through regional metropolitan areas. Underpinning this is a commitment and understanding around how we enable clean, sustainable energy and also build resilience into these mobility systems so that we aren't just solving for problems today, but really building robust solutions that will work well into the future. And these personal mobility and harmony and mobility are connected. And one of the fundamental ways they are connected is through the concept of of equity and understanding that the solutions we bring can't increase the divide, but must be beneficial to everyone across society. And this concept is also one of the important reasons why we've greatly appreciated our collaboration with the Alan Turing Institute because of their deep expertise and understanding of these equity issues and ethical issues that underpin this. So what does this really mean, and what do we want to really talk about today? And this is our program on AI and machine learning for urban traffic control, which is moving towards this idea of resilience by design. If we look at where we are today with traditional traffic management, even with the improvements in technology that have happened over the last several years, we are still faced with a lot of congestion and challenges in adapting and reacting to what happens in real time and acute events that are occurring throughout an entire metropolitan-wide mobility system. So our work with the Turing, which Damon will go into more detail on, was built on this idea of, can we move from adjusting signal timing at individual intersections to trying to create an optimized system across the entire metropolitan area and do so in real time so that we can adapt to things that are happening based on weather conditions. If there's a sporting event, there's an accident, or just the changes in demand that fluctuate and occur in random ways and sometimes predictable ways throughout the day. But the ultimate goal is really to evolve into this resilient mobility system where we can have this ability to manage a system if entire parts of it might be disrupted for extended periods of time. And going back to this idea of equity, we have to be able to understand the possible trade-offs. And in order to understand and manage these possible trade-offs, we have to be able to visualize and understand the data and what the system is doing and how it's behaving and how it's performing for all these individuals, both at a systemic level and acute level. And do so in a way that empowers the people who are managing these systems to make decisions. They may want to prioritize certain aspects and deprioritize others, or they may want to ensure that there's a minimum level of service and attribute across the spectrum of these equity metrics and the different aspects that the mobility service is trying to provide. And so with that background, I hope I've created a framework for the motivation for what Damon will now go into detail and explain where we are with this mobility system, with a real focus on what we are calling the Mobility Data Toolkit, which is a way to take this complex data and the AI and the machine learning that goes that underpins it and produces results, and put it into a form that is easy to understand, easy to use, easy to interpret, and empowers the mobility managers to execute on their mission to provide effective, safe, reliable, and optimized mobility. So look forward to further discussion on this, and Damon, please continue.
Thank you. Can I share my screen now? Thank you, William. I've already said a little bit about what the Turing Institute does. I want to carry on from William's remarks by saying a little bit about the role of AI in answering the pressing problems in transport and mobility, and to characterize the sorts of problems that the Turing Institute and I think Toyota Mobility Foundation are particularly keen to work on. The problems that we're interested in, where we're interested in applying AI, I'm going to describe them as problems that are both too big and simultaneously too small. Let me explain what I mean by that. There's this space in between, what we might call the Goldilocks zone of AI, which is made up of problems where there's a narrow, well-defined task and where it's reasonably easy to get huge data sets to train your AI on. And perhaps also there's a big market. When there's a big market, these problems are very well suited to the big tech companies. That's not the focus of what we're working on. It's not to say that the Turing Institute doesn't have people who work on problems like this. One of the problems we looked at was, how do we optimize traffic lights across a city? The interesting thing about this problem, you can think of it basically as playing a computer game. It's like a gigantic version of Tetris, where the goal is to clear queues of cars. The AI tool for learning to play games like this is called reinforcement learning, and it's the tool that was behind AlphaGo. We found that we could use it to improve throughput of the city by somewhere in the region of 15%. But I want to talk about different types of problem, the real focus of what William was talking about and the real focus of what the Turing Institute does. Problems that are too big, problems of how to get the best outcomes for everyone in society, especially where there are conflicting interests. Here's an example that I heard about from Transport for London, which manages the roads and public transit in the city. Let's suppose there's congestion at an intersection. This congestion will be picked up by sensors, and someone in the street's control room will spot the problem, and they'll try to reduce traffic by turning the lights red on the streets leading towards this problematic intersection. And so what will happen is that buses will get caught up in traffic, which means that people will find the buses to be unreliable, and so people will decide to travel by car instead. And so next week, the congestion will be even worse. So it's the nature of these two big problems that we have to think about how all the subsystems in a city relate to each other, and about whether a change that we make in one place might have unintended knock-on effects in other parts of the city. Then at the other end, there are problems that are too small. The problems that can't be solved by software engineers and researchers like me sitting in a tech campus on the other side of the planet. Problems that are about addressing the specific needs of particular communities and which need people on the ground who understand their local needs. I'm going to be walking through one particular example about e-scooters in a moment. But before going on to the details about that, let me just summarize. Let me say a bit more about these big, small problems. These are the types of problems where what we really need to do is we need to connect governance and communities and researchers. And that's the strong spot of the Alan Turing Institute and of the Toyota Mobility Foundation. It's what we were set up to do. I'm working on these big, small problems in the realm of transport. And so my focus is on how I, as a researcher, can help local decision makers, especially local city planners and people who run transit systems, by giving them the tools that they need to make their decisions. So this is what William referred to, the Mobility Data Toolkit. I'm calling it the Excel for mobility data. Let me show you the sorts of big, small problems that it's designed for. Here's a clipping from a newspaper interview with Salita Reynolds, who runs the Los Angeles Department of Transport. Los Angeles, like many other cities, was facing a rash of companies who wanted to put in e-scooters, and the city wanted to make sure that they were run so that these scooters would serve the social good, rather than just the bottom lines for these companies. So Los Angeles created a data format and told the e-scooter companies they had to use that standardized data format to send their data to the city, and then the city could keep tabs on them. It could make sure that neighborhoods with public transport, like the green area here, were given enough scooters, and make sure that the busy downtown areas, like the purple one, didn't end up with too many scooters clogging up the footpaths. So here's how the city could use our mobility data toolkit to keep tabs on the problem here. This is what it looks like when you open the toolkit. You see a dashboard and it invites you to open the data set. Load in a GPS telemetry dataset. This has GPS readings from e-scooters from several companies. Double-click them to show each individual trace. This dataset has an event column which marks the start and end of each trip. Use this to label each device by when it was active or idle. The data toolkit understands that this dataset describes real-world things, and so it interpolates between readings. Filter out the active periods. Load a map file with the city regions of interest and link the e-scooter dataset with the map. Color code the scooters by region, group by region and by e-scooter company. Count the number of devices per region and per company at each point in time. The data toolkit keeps track of how all the tables relate to each other. Each company owns e-scooters, each e-scooter has readings, and so on. So it knows what we mean by count the number of e-scooters. We've plotted the number of idle scooters by region and by company at each point in time. I hope the subtitles made sense. I'm very sorry, I don't speak Japanese, so if there are any mistakes, please accept my apologies. All right, so what's the big deal about this toolkit? What's really clever about it is that it's all usable by non-programmers. Anyone who has the skill level to use Excel should be able to pick this up. If you asked a data scientist at a big tech company like Google to do this analysis using the tools that are out there at the moment, it would take them several days of programming. I know, I've been there, I've worked through this, I've talked to them, this is what it would take. But without Toolkit, I zoomed through it very quickly, but without Toolkit you can do this analysis in just about 5 minutes of pointing and clicking. I like to describe this as digital data science. Digital in the sense that you do it with your hands, your digits. It's all done by clicking and dragging and grabbing the things I have more demos showing all the different ways you can tease apart your data and grab some and merge pieces together. I won't go on about that, but anyway, that's what I love about this. It brings back the feel of these science fiction shows where you're really interacting with your data. So this is what the Mobility Data Toolkit looks like for certain simple use cases. I also want to talk about the other side of what the toolkit can do. A better version of Excel is, of course, massively useful, no doubt about that, but it's not as sexy as artificial intelligence and machine learning. So I just want to show you and talk through some applications of machine learning inside the data toolkit. This is the problem I want to talk about. The problem of understanding how public transport, like buses, fit in with the new mobility services that are being offered by companies like Uber, and how users, how citizens of a city will be making the choice between them. Let me turn back to Salita Reynolds, the head of the Los Angeles Department of Transport, and hear from her words. What she's describing in this magazine article is a city which intelligently regulates these new transit companies like Uber. And the way she's envisaging it is the city will set smart tariffs so that the companies are incentivized to reduce congestion. The companies are incentivized to move away from places where it's too crowded, and they're incentivized to move towards places where the city wants them to move. What makes this fiendishly complicated is that there's this feedback loop going on. We have three subsystems going on here. We have the users, we have the transport companies, and we have public transit. If the city intervenes on prices, this will affect the choices that users make, which will change how much they want to use these companies like Uber, which may then institute surge pricing. That's the standard mechanism that these companies use to deal with excess demand. And that will change the choices that people make and so on. So we've got a feedback loop. If you make a change in one place, you will have knock-on effects throughout the entire city. I warned at the beginning about the big problems with unintended knock-on effects. And this sort of system is so complicated, it's almost begging for unintended consequences. At the Turing, we've been working on this. We built a model which has two parts. There's a classic economics model for revenue optimization, which it's reasonable for us to assume that the transport companies will be running. And then there's an AI model that we trained based on trip diaries, which give examples of patterns of trips that people make. You know, there are commuters, there are tourists, there are shoppers, and so on. And they all have different patterns of behavior, and they'll all respond differently to pricing and to congestion. So we trained a model for this. Interestingly, it uses the same sort of AI that people use to model text. You know, text is made up of words in a sequence, and travel patterns are made up of trips in sequence. So qualitatively, it's the same class of model. And then there's the really clever bit. This is novel work. I'm really excited about it. We found a way to link these two together. Basically, we're sort of unwrapping the neural network model, and we're feeding it into an economics model. Now, I won't go through the maths of all that. This isn't the place for that. I'll show you what matters more about it in the end. How people, how city planners and so on can make use of this modeling. Let's switch back to our mobility data toolkit. Load in a trip diary dataset. Load in the trained ML model. This model expects total demand per travel mode, so we need to aggregate the trip diary data. Group trips by their origin, destination, and mode, and count the total for each group. Simply drag our demand table into the ML model, and it predicts the usage of each travel mode. We can put the original data side by side with these predictions and investigate the differences. That last comment there, the comment about putting the machine learning output side by side with other data, is what I really like about this toolkit. It's a way to make it so that analyzing your data, exploring machine learning models and predictions, testing out scenarios, they're part of the same thing. So in summary, it's not enough to just invent an AI algorithm. What you really have to do is find ways to put the AI algorithm into the hands of people on the ground, people who understand the data they're working with, so that they can use it as part of their decision-making process. I have several more demos I could show of how the Mobility Data Toolkit would be useful, but rather than me talking on and on with more and more demos, I'd like to hand back to the chair now so that we can have a bit of a discussion.
はい、ウィリアムさん、デーモンさん、素晴らしいプレゼンテーションありがとうございました。モビリティデータツールキットの、ご紹介もありがとうございます。それではここから Q&A セッションに入らせていただきます。ご質問が終わりの方は YouTube のコメントファンクションをご利用いただけますでしょうか。それでは皆様からのご質問をお待ちする間に私から
as we wait for the questions, I'd like to ask questions to the two gentlemen. So we talked about the mobility data toolkit.
このようなツールキットがなぜこれまで開発されてこなかったと思われます
Why is it that such toolkit was not developed up to now? And
成果を見ない中でこのツ
as
ール
we
キッ
don't
トが
see
成功する
similar
と思う
developments,
理由をお二人は
similar developments, why do you think that this toolkit is going to succeed?
Yes, I think that's a very relevant and important question. I'm not entirely sure why it may not have been developed prior, but I think some of that comes from maybe, or maybe I can answer that by saying, why is it being developed now? And from the foundation's perspective, when we were engaging with our partners, whether it's the transit agencies and organizations in Japan or the US or in the UK, we started to see and hear and understand that there was this underlying problem. And it's our ability to be close to the problem that, as Damon said, bridge that connection between the local problems and these two big problems. To recognize that there was an opportunity and a need to develop this. And it wasn't something that we found had been developed by other partners and may, because it was such a specialized problem, may not have been in some companies' interests or they didn't have the motivation to do this. But because this was very important for the public good, it was well aligned for the Mobility Foundation to tackle this challenge and work with the expertise that we had, were able to bring in with at the Alan Turing Institute.
Can I give a little bit of a historical perspective in addition to what William said? William was looking towards the future. I'm going to look towards the past and the history of this sort of toolkit, data toolkit approach. A little bit of history. The first spreadsheet, VisiCalc, was invented in 1979. After that, there was Excel in 1987, and another product which many cities use, Tableau, 2003. Tableau is basically the fulfillment of those ideas from VisiCalc. It takes roughly 20 years for an idea of how we should work with data to turn into its final form of a lovely, usable piece of software. All of these things, spreadsheet, the earliest spreadsheet up to Tableau, are purely about working with tables of numbers. They were designed for people who want to work with financial data, which is basically tables. Another strand of work is people who want to work with spatial data. A tool widely used in cities is ArcGIS, and the first serious release of that, 1999, and the first serious software library, GEOS, for dealing with spatial data, made public in the year 2000. Interestingly, this software library, it was developed in British Columbia by the Forestry Division. They obviously have lots of land they want to keep track of. Anyway, so we've got two strands of general purpose tool. One strand working on tables of data, started in 1980, took about 20 years. One strand working on spatial data, first serious release, 1999, is what people are still using today. Now, spatial data, those tools are wonderful if what you have is financial data or if what you have is spatial data. The characteristic of the trees in the Forestry Department of British Columbia, they don't move very much. Well, we care about things that move, and things that move are basically a different data type. And simply speaking, no one has embarked on trying to produce a general purpose tool for dealing with things that move. There are lots and lots and lots of special purpose tools that people produce. This is part of the problem, in fact. Every city which had a specific need to, if it was advanced, it would roll out to a group of data scientists and they'd produce a dashboard which solved their specific problem, and it wasn't transferable. It's only very rarely that people decide, hey, I want to turn this into a really general purpose tool which will solve a whole host of problems. And that's what we're trying to do here. I mentioned before, I used to be in a startup in Silicon Valley. We tried to do this thing there, actually. We started 8 years ago. We started trying to build a toolkit, a dashboard for working with things that move, and we failed. The trouble is companies can't do this very well. Startups can't do it because the people they want to work with are cities, and cities work on a slow timescale. And they don't trust that the startup will be there 3 years from now. They don't want to deal with a small company who's going to go bust. And big companies don't want to jump into this either. What's the point in producing a general purpose tool? The only way it can be general purpose and widespread is if it's open source, if everyone takes it up. And what's the revenue for the big company in doing that? It's only through something like Toyota Mobility Foundation and Alan Turing Institute that there's actually the resources to step back and think, hey, we need to work on a general purpose tool. We've had enough of cities working on their own individual dashboards all the time. We want to create something that can be a common platform that lots of people can use. And that really does take the resources of something like Toyota Mobility Foundation, linking in with researchers at a place like the Turing Institute.
はい、ありがとうございました。
So thank you very
残り時間
much.
わずかとなりまし
So
たけ
we
れど
have
も、
just
視
a
聴者
few
の
more
方から
minutes
1
remaining,
点
but
ご
we
質
do
問をい
have
ただ
one
いております。
questions for
ウィルさん
our
はチャッ
viewers.
トで回答をいただいておりますけれ
You've
ども、
already
何か補
responded
足
on
されたい
chat,
こと
but
は
is
あ
there
ります
anything
でしょう
that
か。
you want to add to your response?
I'm having trouble seeing the chat, so
では質問を今から読み上げます。
In that case, let me read out the question.
はい、交通渋滞の原因は国
The
や都市によって
congestion,
全く違います。
I think the
東京、
reason
ロ
is
ンドン、
different
北京、
from
ジャカルタ等を比べると分
from
かるよう
Japan,
に、それぞれの
Jakarta,
道路網の
Beijing,
発展の
the
歴史
road
経緯や
development
生活上の
and the
ニーズ
daily needs and manners are different according to each countries and cities. At Toyota Mobility Fund, what are you doing POC at other cities? And are you making that learned by AI and are coming up with measures according to each countries and cities? Have you conducted a POC at a particular country or city? So if you could answer in short, that'd be great.
yeah, so the system that we're developing has the capability to do the learning and adapt to the different cultural and local attributes of each of the cities. Right now, the training has been primarily focused on cities in the UK, but the intent is to make this applicable globally because the fundamental structure works and is able to adapt and accommodate the priorities and needs, if you remember those equity frameworks, that the individual traffic managers can adjust how they want to prioritize, and the machine learning will train and adapt to what's happening at the individual cities where this would be deployed in the future.
はい、ありがとうございました。
If I could just remark briefly,
え、
that's the
私
great thing. That's why I wanted to work with Toyota Mobility Foundation. They have global reach. They have projects going on all over the world. And so that's a great way to get this sort of thing spread.
はい、ありがとうございました。
Thank you very much.
最後になりますけれども、
So,
英国大使館では日本企業と英国の
at the UK Embassy, we are supporting the research support, so I would like to ask, have more two questions.
研究機関との将来的なコラボレーションについてご関心がおありの方は、
And if you are interested in the collaboration between UK and Japanese companies, please let us know. You can actually search on the internet the future of mobility embassy, UK embassy in Tokyo. You can actually bring up the question form. So please use that. And that concludes the session. Mr. William, Mr. Damon, thank you very much for your valuable time today. And everyone, thank you very much for attending this session.
のためのデータサイエンスと AI、交通とモビリティ、
And this concludes the data science and AI for social good collaboration on transport and mobility applications.
次のセッションは
The next session
15時からとなります。
starts at 3 o'clock.
お時間ま
3 o'clock.
で今しばらくお待ちくださいませ。
And thank you very much for your patience until 3 o'clock. The next session starts at 3 o'clock.